So we're going to continue and work on problem 3 from the notes, writing an equation of a perpendicular line. Same idea as what the example we just looked at. We want the line to pass through this point, and we want it to be perpendicular to the graph of this line. And again, they want us to write the equation in slope-intercept form. So I'm going to start by identifying our slope. So in the original equation, the slope was 2, but we want the new equation to be perpendicular. So that means we have to flip it and make it the opposite sign. So that's going to mean we have a -1/2 for our perpendicular slope. The next thing we want to do is start with point slope form. So y minus the y1, which is 8, equals our new slope here, -1/2, and then x minus 1. So it's going through this point and it's using our new perpendicular slope. Now I just need to simplify and get it into slope-intercept form. So we're going to do -1/2 x. That becomes +1/2. And then we want to move the 8 over. So we would end up with y equals -1/2 x plus 8.5 as our equation. So here we have our equation in slope-intercept form. It has a perpendicular slope and it goes through the point 1, 8. So here we have a question. We have two lines that are perpendicular to each other. The slope of a line is 2. So what is the slope of a line that is perpendicular to that line? Well, we talked about how they have to be opposite reciprocals, and we just did this on the last problem. So it's going to have to be d, because we have to flip it. So 2 over 1, you flip it, and then you make it the opposite sign. So the last question is more of that word. So sorry, I must have pressed pause accidentally. So I'm going to go back to example 4 real quick. In example 4, we're talking about an architect that's using software to design a ceiling. The architect needs to enter an equation that represents this new beam, and the new beam will be parallel to the existing beam. So mathematically, we could say, okay, well, if the slope of this beam is -8/12, then, or simplified to -2/3, then we would take this point and -2/3 and plug it in for our point slope form. And we would simplify, use distributive property, then add the 10. So one way to get that equation is by solving it mathematically. We could also see that if we have 0, 10 as our point here, and it has to go through that point, and we know it has to have the same slope, I already know it has to go through 10, and I already know the slope has to be -2/3. So technically, we wouldn't really need to do this part, but I still think it's good for you to see that relationship. Now moving to the lesson check. How is determining if two lines are parallel similar to determining if they are perpendicular? And how are the processes different? So if we look here, to determine if two lines are parallel, what do we need to do? So we need to think about the slopes. So we have to make sure that the slopes are the same. So the slopes must be the same. 22, to determine if two lines are perpendicular, what do we need to do? Well, we've talked about the slopes again, but the slopes must be opposite reciprocals. I'm going to just abbreviate opposite. So opposite reciprocals. And now think about how the processes are similar. Well, for almost all of the problems, we started with point slope form. How are they different? Well, think about they have to have their rules for the slopes are different. And obviously, parallel lines never are going to intersect, where perpendicular lines intersect at 90-degree angles. We also could say they use different symbols for parallel, different symbol for perpendicular. So there are a lot of kind of different things we could put in 23 and 24, just kind of comparing as we go through. So your job now is to complete the assignment that is in your notes packet over this section and get some practice with parallel and perpendicular lines.